I'm Greg Wolffe, GW, Professor of Computer Science in the School of Computing at Grand Valley State. And this is my lab, the Den. The Den is first and foremost a facility for student research. So this was originally created, in the last millennia. And as my background is parallel and distributed computing, our first system in here was a high-performance computing cluster, a Wolffe-style cluster. What we did is started with procuring a small, a modest grant for networking hardware, routers, switches, KVMs, solicited donations from industry for things like racks and displays, and then got a number of older surplus machines donated from our internal Grand Valley's IT department, and we built a cluster with about 32 nodes. Basically, a solution in search of a problem. So what kind of a problem? In those days, most of the big problems came from the sciences. Where would you apply supercomputing or high performance? Large genomics searching, chemistry simulations, physics solvers and things like that. So computational science. And these are the original areas that our students worked in, and we became known as the source of big problems within the department. And so as mentioned, we were intended, the original vision of this was to introduce students to research and give them a taste of what graduate school would be like. So we tried to create an environment a lot like being a graduate student, where the student would get their own desk and their own workstation. We encouraged them to make it their home. So they got a refrigerator, a microwave, espresso machine, everything they need. They work on projects in here, do homework on the board, and of course, work on their research with an advisor right down the hall asking if the latest batch of experiments are done yet. So a lot like the graduate school experience. It gives them a chance to see if they like it, and if they do, it's a big advantage for them in that they have experienced this research before and hopefully have a publication as a result of it. So we try to take them through the whole process, from writing the grant, through building the machines, doing the research, and disseminating the results. So that's the typical scenario. For example, with Ghost, which is our latest deep learning workstation, procured an equipment grant for Ryzen Threadripper CPU, 128 gig of RAM, the latest high-end deep learning GPU from NVIDIA. Students spec it out, they build it, then they also, prior to their work, write up another grant to get a stipend and propose a research project, design algorithms, work it out, experiment, discuss results, visualize, justify, defend, and then hopefully take first author role in writing up a paper. So that's the idea from the student research emphasis of this lab. Now, of course, it evolved over time. We cover all of the main paradigms in high-performance computing. So a lot of multi-threading, a lot of cluster computing, moved into GPU computing, and cloud computing. So we built a number of clusters and Hadoop clusters and small clouds in here as well. And we've also evolved to move from computational science into, as big data appeared everywhere, storage, high throughput computing to handle big data, as machine learning and deep learning grew in popularity, new workstations. So high performance, by definition, is the leading edge, state-of-the-art research. So whatever that is, that's what we attempt to do in here. This lab also evolved to start supporting various classes. So 380 parallel algorithms, of course, 451, computer architecture, looked at some of the new technologies like GPUs. 452, operating systems, deals heavily with multi-threading. This supported 656, our graduate distributed computing class, used Hadoop clusters in here. It definitely supports 677, graduate course in high performance computing, and now also 678, machine learning, with needing deep learning for some of the training that we're doing and ongoing research. There have also been a number of other faculty involved in here, Drs. Treffs and Scripps, also Drs. Ingelsma and Leidig, and then more recently Dr. Moore and Dr. Carrier. So there have been a number of people here and a lot of students over the years, with also some help from our very capable sysadmins. Where we are today, a high-performance, big data, deep learning, computational science student research lab. Thanks for stopping by.